the meat. The meat. We have the meat. So this is the heart of really the session and the morning session and what we're going to be talking about in the morning session. And so you're going to learn a little bit about who you are. You're going to learn a little bit about who the other people in your room are, because we're going to talk about your strengths and what interests you and the things that you place a lot of value on. So family, friends, intelligence, saving the world. You know, some people, that's one of the most important values to them. We're going to learn a little bit about the Qualcomm Corporation. We're going to learn a lot about engineering careers. So you are going to be hearing a lot more about engineering than you may have in any other camp, mainly because I'm an engineer. So the fact that I am an engineer, you're going to get the flavor of me thinking that engineering is one of the coolest careers you could ever want to take or go into, because it can take you so many places. We're going to learn about circuitry. We're going to learn about the Arduino itself, the little circuit board that you got in your SparkFun kit. We're going to learn about coding, which is just another language. It's a way to communicate, and it's a way that machines and people can communicate. We're going to do the engineering design process, and then we're going to invent an IoT, an Internet of Things wearable device. How many people have heard the term Internet of Things? Let me just see a show of hands. A, yay, I've heard it. I've heard of it, or no, I've never heard of it. It's like, yeah, forget it. Thumbs up. Yeah, I'm seeing a few people that have heard of it. So we're going to be talking a lot more about the Internet of Things. And if you haven't seen it already mentioned in any news or any kind of features in magazines like Wired magazines, it's really the way that we're going to be connecting the world and having the internet help us accomplish tasks. Next slide. So Qualcomm, who is Qualcomm? And there are a lot of companies that do telecom. And Qualcomm, we kind of take it for granted today that we can connect in seconds from virtually anywhere with apps that make work certainly more productive. And Qualcomm is really a company of inventors. If you notice, I think in your book, there might even be a mistake on it. It says a company of investors. They're not. Well, they probably are investing too, but they are definitely inventing. And they really believe strongly as a company, as a corporation, one of their values is inspiring the next generation of engineers and inventors, because they understand that a company is not made up of buildings, it's made up of people, and it's made up of social and physical capital. So we are going to be sharing some information about Qualcomm, and throughout the week, you're going to take on the role of both an inventor or an engineer as we go through and invent an automated hat design. So CDMA technology is really what we're going to be talking about. And I'm looking, okay. So, and I'm looking for the slide that tells me what it stands for. Anybody know? Code division multiple access. There you go. And it's really for mobile communications. And as we've gone through time, what's really important is to get to the ability to do, to be able to communicate quickly across all kinds of depending on where you are, all kinds of places. Let me get out of here and go back. Sorry about that. I opened the wrong file. And I just confused myself. Okay. So every day we're going to really start the day with the Qualcomm session. And this first part was sponsored by Qualcomm, and this year it's actually sponsored heavily by Qualcomm. So that means they've funded us. They provided us money. They've actually been our partner in San Diego for the last 6 years, and they are located in San Diego. They so understanding just a little bit about them is really important as you're going to design an internet of things that utilize wearable tech. And wearable tech means this is wearable tech. So what do I have on my wrist? I have a Fitbit on my wrist. And those of you who also have Fitbits or Apple phones or whatever, that's wearable tech. That's something where you have something that you're physically wearing that is communicating through Bluetooth or something else. So who exactly are they? This was founded in 1985, and which is a little bit before most of your time. Erwin Jacobs and 6 other engineers founded it here in just like a lot of them, they found it in a small building and then they expand when they start adding more people. Their name comes from quality communication. So they are inventors, and they really are the ones who help put the smart in smartphones. So you have phones that used to be just something that you dialed and you picked up and you talked on it. Now they can do so much more. And so their job is really to be focused on this code division multiple access, which is a way for technology to communicate more effectively. But they weren't the first to come up with this idea. Next slide. So the first one was actually, you may not recognize this next person. Next slide, Tara. You may not recognize this actress, Hedy Lamarr, who was an inventor. And she and a musical composer basically came up with the idea of using frequencies and frequency modulation to deliver data in between. And so that whole concept of frequency hopping, and it was really, they developed it in order to help with some of the coding. Those of you, there's a couple movies that have been out over the years about women and men who have done some of the coding in Europe during World War II, trying to be able to figure out what spy work, trying to figure out what other people are doing. They did patent the idea, and they gave it to the US government to share during World War II. And so, but most people didn't pay attention to it because they were too busy worrying about other things at the time, and eventually the patent expired. And so we take it for granted. We definitely take for granted that we can get communication with other people instantaneously. And whereas before, maybe you used to have to wait for a while, but now with wireless technology, we have apps that can make you more productive. They can make it more fun. And it's possible to that we can now work on making the next step, which is to be able to communicate wirelessly worldwide and almost instantaneously. Next slide. And it almost wasn't. So CDMA. So in CDMA, you are actually, instead of sending a message all by itself, you send it in code. And so it used to be called time division multiple access. So it was really dependent on this piece of information goes at this time, this piece goes at this time. And what they've done is they've been able to put it in code so it goes all mixed up, and then it ends up getting to the right place at the other end. It's scrambled, and then it's reconstructed at the receiving end. Then what this does is it enables multiple users to speak at the same time. It allows more conversations to be delivered on the same amount of bandwidth. There's the same amount of spectrum or frequencies. And at the time in the 80s, this was really a risk for Qualcomm because nobody else was doing it. But as an inventor, that's one of probably the most important things that they can think about, is the fact if you don't take risks, you won't discover anything. You really, Thomas Edison, how many different designs did he have to, inventions did he have to come up with before he found the light bulb? And it was like 5,999 before he finally was able to do the 6,001 to make light bulbs a real thing. So now we're going to watch a quick little video here. Whoops, sorry. Let me turn this off. And don't forget to, on the next slide, if you can make sure that you check the sound box, please, Tara.
Yeah, of course. I'm just going to re-share my screen so I can share the sound as well.
Thank you. Yep.
The industry had looked and seen that the cellular business was really growing, but staying with analog with first generation FM radios was not the right solution. How do we go digital? Companies around the world had looked at CDMA, played with it a while, and they had all thrown it away, and had gone with PDMA or FDMA. One of the things did catch their attention, that rather than perhaps a 3-to-1 improvement in the number of customers you could accommodate in a given antenna in a given bandwidth, with CDMA, we came to the point that would be 10 to 20. It would provide a significant economic advantage by being able to get many more users into the same amount of spectrum. I thought there was about a 50% probability that somebody was going to be able to raise their hand and say, you forgot about this, and this is why it's not going to work. Nobody did. So the next step we had to do was build a demonstration system. We worked day and night to prepare 2 base stations and a mobile terminal for a demonstration. We knew we couldn't wait too long because the industry was rushing ahead with TDMA, and if we missed that window, we'd have to wait for a 3rd generation. And so we had to move quickly. In September, I had to make a decision whether to send out invitations for people to come in to see our demonstrations beginning of November or not. And probably 85 or 90% of the engineers felt we better wait and decided to go ahead and send out the invitations. Beginning in November, everybody showed up here in San Diego. We had about 120 people, and we had several people make presentations on CDMA. Then I was making the last presentation and getting ready to send everybody out when one of the engineers in the back of the room began to wave at me and to keep talking. And so I kept talking. Being a university professor, adding 45 minutes or 50 minutes to a talk is easy. It was about 50 minutes later, another wave came that it was okay to send people out, luckily. Probably another half an hour, people would have realized something was wrong, and there would have been no Qualcomm.
Awesome. I was looking at that with the, and it wasn't intentional, but on that movie, next slide, on that movie, that little last picture with the guy with all the towers all over his head reminded me of a COVID molecule. I don't know why. I looked at that and said, it's kind of timely. Anyway, so Qualcomm is what they call a fabless, not a fabulous, but they are fabulous, but a fabless. That means there's no fabrication involved. So they're a fabless semiconductor company. So they produce the technology. They're the ones that come up with the design for the technology, but somebody else makes the chips. So they do not manufacture the chips themselves. They make money by creating the design for the chips, the chipsets, and the other way that they do it is through patents. So they have over 6,000 patents that they've used for various ideas. And one of the most notable of these is airplane mode. How many of you have ever been in an airplane and the flight attendant tells you to put your phone on airplane mode? That's one of the patents that they have. And patents, by the way, we won't go a lot into patents, but they're basically supposed to be for 20 years, which means after 20 years, it's possible to come up with something a little bit different and get a patent for basically the same thing, tweaked just a little bit differently. So 20 years is not really that long a period of time when you're in the manufacturing business and a long time company. So how old they're now? They're almost 40 years old, Qualcomm. So 6,000 patents. I'm sure most of them have probably expired at this point in time, but there's a lot of other things that they're going in, the lock screen, app, voice recognition. And so most companies like Qualcomm will work with major phone manufacturers and cell phone carriers, and that's their predominant business. And they then have become a leader in the most recent technology, which is 5G. So let's go to the next page. So this is just a little bit more information about patents. You can look into it. So how did they make money? And so patents, they protect an inventor's ideas. If you want to produce a product that has a patent, what happens is other people have to pay you a licensing fee in order to use your patent, your design, in manufacturing something else. So when an inventor, and I have applied for patents before, but I actually applied for a patent with a company I work for a service. So it was not an actual product. It was when they were first starting to talk about patents for services. And you have to apply, and you have to put a lot of details into drawings. You have to put some specifications. You have to put all the engineering descriptions in there that are going to help you and are going to narrow the focus into something that is patentable. And we're not going to be applying for any patents for anything that you're going to be doing here, but you could in the future if you were to want to. And maybe you're going to come up with something in the next week that's going to be brilliant, and Qualcomm will want to get your patent. So that's something that you need to be thinking about all the time. What can you do? Save your sketches of your designs, save your ideas, and talk to other people about your ideas. It's possible that it may be patentable. They may pay you. Next page. So let's look at the dishwashing, this dishwasher. So this is a patent for an early dishwasher, and it was put together by a socialite. A socialite is a rich person that spends most of their time just either trying to fundraise for a special cause, or they don't. This particular socialite, Josephine Cochran, she was looking for, she discovered that the people who were washing her china were chipping her china. And so she decided it was going to be important for her to come up with a way to, decided she didn't want to do it herself because, you know, she didn't want to wash dishes. And so she, at the time, most things that were doing activities like that were using scrubbers, and she found out using water pressure was really the solution. She ended up talking to a couple people about maybe buying the idea for her design or building it, but then she decided to get the patent herself, and she started her own washing machine company, the Cochran's Crescent Washing Machine Company. But it was actually too expensive for the average person, and so she would just sell to hotels and restaurants, which is a very real possibility. Next slide, please. So let's talk a little bit about 5G and what 5G is. Since CDMA was introduced back in the 1980s, we've come a really long way in terms of technology. So if you think of, and I used to have one of these large size portable phones when I was just starting out as an engineer in the 1980s. we had to do, I was a field engineer, which meant I had to be on the road all the time. And so you had to have a way to communicate. But what you had your phone in was this big pack. So the battery pack was way bigger than the phone at the time. And so what does G stand for? It stands for generations. So you have first generation, 2 generation, 3rd generation, 4th generation, and now we're finally in the 5th generation. And so the first cell phones were 1Gs. That was pretty basic. They call it analog. There was not a lot of digital anything going on. It meant you could only call and you could talk to someone, and it really had nothing else that it could do. And then with CDMA in the late 80s, mid to late 80s, came 2G, which actually enabled the first digital phone, and it allowed users to now call. That was when we first started SMSing, texting with very simple text messages, and to be able to send pictures. And then 3G in early 2000, that was the first smartphone. So that was, now you can do a lot more. You can connect to the internet. You can use GPS technology to tell where people are. And then 4G, it just got faster. It's talking about being able to download even faster, to stream movies, it's just going to see faster connections and download. And then 5G is all about, and we'll talk a little bit more about 5G and how that is different and its connection to the Internet of Things. So the next slide, please. I believe this is a video, and it's going to talk a little bit about understanding 1G through 5G.
Every new generation of wireless networks delivers faster speeds and more functionality to our smartphones. 1G brought us the very first cell phones, 2G let us text for the first time, 3G brought us online, and 4G delivered the speeds that we enjoy today. But as more users come online, 4G networks have just about reached the limit of what they're capable of at a time when users want even more data for their smartphones and devices. Now we're headed toward 5G, the next generation of wireless. It will be able to handle 1,000 times more traffic than today's networks, and it'll be up to 10 times faster than 4G LTE. Just imagine downloading an HD movie in under a second, and then let your imagination run wild. 5G will be the foundation for virtual reality, autonomous driving, the Internet of Things, and stuff we can't even yet imagine.
Okay, I guess we can't imagine it, but we'll try to imagine it. Let's keep going. I mean, don't bother playing it again. So let's just take a look at the bytes per second. How many bytes per second that each generation is capable of? So if you look at 3G, where are they at? They're at 10, they're at about 1,000 bytes per second. In 4G, we've now gone up to 1,000,000 bytes per second. And when we get up to 5G, we're talking about billions of bytes per second. So that is really, really fast, the level that we're communicating in. And it's just going to expand our ecosystem. It's going to affect every industry that we have. It's going to make transportation safer because we'll be able to communicate about where cars are, where vehicles, where trains are instantaneously. It's going to help with remote healthcare, agriculture. There are so many areas that 5G is going to touch and make a fantastic reality. Let's go to the next page. So let's talk a little bit about the Internet of Things. And what the Internet of Things is in simple terms. It takes everyday normal items and it makes them smart. So a good example would be your refrigerator. Having a smart refrigerator. Does anybody have a smart refrigerator? I don't have one. Anybody in the room here have a smart refrigerator at home? Have one of those refrigerators that talk to you? I thought about getting a washing machine. You know, they had the ability to get a smart washer and dryer set where the washing machine that would talk to the dryer and tell it what kind of, what cycle it just put things through. And then the dryer would talk back and say, okay, then I'll dry it for this long. Or it was just, to me, it's like, no, that's way too complicated, way, way more complicated than I want to get. Soraya, do you have a question? No? Okay. So the smart refrigerator would be able to, so you go shopping and you bring something home and it reads your barcode as you're putting it into the refrigerator. So when it reads the barcode on the package, it knows the date you bought it. It knows what the product is. It can make some inferences or talk to the internet about, well, how long before this expires, and do a lot of things that maybe you had to do in the past, or your mom or your dad had to do in the past to remember that, oh, that thing is more than 5 weeks old, so I better throw it out, or whatever. So it is really one of those ability to take information and to do something with the information. Next slide. And this is going to talk to you a little bit about how 5G actually works.
What is 5G, and what makes it so different from anything we've ever experienced? 5G is the next generation of wireless that will redefine the ways we connect to the world around us. 5G will make possible a connectivity fabric that weaves everything and everyone together, creating new business and economic opportunities around the globe. The new innovations behind 5G will deliver data faster, with less lag and even more reliability. To better understand 5G, it is important to know a little about radio waves and how they work. Your smartphone and other wireless devices use very specific frequencies on the radio frequency spectrum to send and receive data. As we use more devices and data, those radio frequencies have gotten crowded. Think about a highway. As traffic builds up, it is important to upgrade or even rebuild the highway system to handle more cars and speed the flow of traffic. It's the same idea with wireless communications. The engineers behind 5G have invented new ways to utilize radio spectrum so that the network can handle 100 times more data than 4G, faster and more reliably. This new capacity is possible because of two important technological breakthroughs. The first is the use of millimeter waves, short radio waves in higher radio frequency bands. For decades, researchers believed it was impossible to use these bands of spectrum for cellular. High-frequency millimeter waves don't travel well through objects or buildings. Even leaves on a tree can block a signal. In 5G, engineers have broken this barrier, opening a giant express lane for data. The second breakthrough is massive MIMO, which stands for multiple input, multiple output. Massive MIMO base stations have dozens more antennas, and they're able to send out concentrated, hyper-precise beam-form signals to a particular user. These beams can bounce from base station to base station to relay signals around obstacles and avoid interruptions. Another important 5G invention opens new pathways for the kinds of data that just can't wait to prioritize critical data and allow it to transmit almost immediately. 5G will redefine work, education, healthcare, and deliver a new level of connectivity to rural communities. It's taken almost 4 decades and tens of billions of dollars in research and development to get to 5G. Wireless technology has already transformed our world. 5G will open the door to possibilities we haven't even imagined yet.
Yes, it will. Next slide, please. So we're going to quickly play a little matching game here, and then we're going to talk a little bit about the challenges and get prepared to go into our breakout room. So how many of you have your book? If you have your notebook, why don't you go ahead and grab it? For those of you who don't have your kit yet, you can follow along on the screen with us. We'll go through this on the screen. And so we're going to talk a little bit about 1G through 5G and which one. And what I'm going to do is allow you to shout out the answers so that we can make this go fast. So I'm going to have you unmute and don't shout it till I ask for it, please. So where would, I forget how this goes. It's digital voice calls, text, and where's 1G? Does anybody know which one is 1G? Any thoughts?
Analog voice calls only.
Let's click it and see. Why don't you click it once, Alexis? Yay, okay, how about 2G?
Is it first smartphones with mobile internet and GPS tracking?
No.
Digital voice
Digital voice calls, text, and picture messaging.
Digital voice calls, text, and picture messaging. Go ahead and click that, Alexis. Thank you. How about 3G?
First
smartphones with mobile internet and GPS tracking.
Yeah.
That's right. That's right. 3G is the first smartphones with mobile internet and GPS tracking. What about 4G?
Surfing the web and streaming HD videos online with smartphones.
That's right. And that, of course, leaves the last one, which is 5G, which is the fastest wireless speeds, download movies in seconds, and instantaneous responses. So let's go to the next slide then. Good job. So this is, think about an Internet of Things. You all are going to be living in this future. You're going to be living in a future where machines are going to be talking to you and asking you, who knows? I always think about this as being, kind of Star Trek-y or whatever in terms of what the capabilities are. But we are really moving into the future pretty quickly, and it's going to open the door to many other possibilities for Internet of Things based inventions. I don't recall how long this video is. Let's see.
Would you like me to play it?
Yeah, why don't you play it? Mm-hmm.
Hi, I'm Emily. I draw cartoons. Today, I'm going to learn about the Internet of Things. Meet Don from Qualcomm. He's going to teach me about the Internet of Things and the evolution of our growing smart world. So Don, the Internet of Things, how smart can a thing really be?
From smartphones to smart homes, smart cars, and even smart cities, the technology is actually advancing pretty fast. However, there's one thing missing from this whole picture, and that is connectivity.
Okay, but how does this actually work? Like if I were gonna draw this out?
All of these things are becoming smarter because people are putting chips inside of things. So let's call that chip a brain. But step 2 in that process is for that brain to program tasks. But step 3 in this whole process is how does that device not only program tasks, but also interact with other devices, making it more connected and then making your world around you thus smarter. In Qualcomm, with our advanced connectivity technologies from advanced Bluetooth to Wi-Fi 11AX, to actually wireless connectivity with 5G, that is the connectivity fabric that's actually benefiting you as well as society as a whole.
How would this smart world really look in the real world?
Why don't I give you a scenario? Okay, so you're planning a dinner party. Your smart oven is telling you what temperature, what time you have to put the meal in, all those good things. But because now it's connected to other devices in your surroundings, it can actually tell your smartwatch you can go for a run while your meal is cooking and still getting back enough time to be able to make sure your meal doesn't burn.
It sounds like I'm really going to be able to outsource a lot of my own personal brain, which is great. But what are the larger implications?
Hi, I'm Emily.
Imagine if you can actually save energy by having not only a smart thermostat, but that thermostat interacting with other devices in your home to make sure that your you're saving energy. So that's what really creating a smarter world with these smarter and connected devices really means from a broader good perspective.
So Don, these things can think, but can they love?
You should hug your oven every once in a while.
But not when it's on.
But not when it's on.
I've made that mistake.
Right, because love can burn.
Oh, wow. Humor. Okay, next slide.
Hi, I'm.
There we go. So, there's 4 different categories of Internet of Things. It's the consumer electronics. That includes things such as the cameras we use, the robots, my Fitbit, that is a consumer electronics. We have smart cities, and that's things like, I'm sure you've seen in many movies where they're able to go in and maybe reroute trains. They're able to reroute subways and just make things operate much better because they're communicating between systems within a city. You have smart homes like our own homes. How many people have Siri or one of the Alexa at home that is helping you turn your TV on or find a movie? And then there are voice and music. So there's a bunch of different things that you can have for Internet of Things. Next page. And let's see, we already looked at that. Now let's go on to, so, let's just have, we're running a little low on time because we did our Q&A at the beginning. And think a little bit about this and how it might apply to the next week for you. What do you find most interesting about the Internet of Things? How could it be used to benefit society? So start scratching your head a little bit and thinking, putting on your thinking cap about that. If you could create any Internet of Thing device, what would you invent and why would you do that? So when you get a chance, not right now, you don't have to spend a lot of time thinking about it right now, but over the next, between now and Monday, because we'll talk a little bit about it Monday too, when we're talking about getting ready for our invention. Think about and be prepared to share your answers. Next slide. And so we're going to do this. I know this was long and you probably don't remember some of these answers, but we'll do the same thing that we did before, which is you can shout out the answers. And so the name Qualcomm, what does that stand for? You have the word bank on the right-hand side. So that definitely should be helpful. You don't have to scratch your head too hard.
That's the quality communication.
Quality communication.
Quality communications.
Quality communication.
Quality communication ideas.
Okay, and so what year was Qualcomm started in?
1985.
1985.
By who?
Irving Jacobs.
Irving Jacobs.
And so what are they? This is the one where it says they're not really a company of investors, but a company of
Inventors.
Right. And so what do they invent?
Tech.
They invent the tech that the world loves. That's correct. How do they make its money?
Through patents and
chipsets.
That's right. Patents and designs for chipsets. And what does a patent protect?
Your ideas.
Right. How many patents do they have?
Over 6,000.
6,000.
And what's one of the inventions that they patented? Now, just by the process of elimination here, we didn't talk at all about what the percentage of engineers versus non-engineers are in Qualcomm, but it's going to be high. A lot of engineers, but they're also going to have some non-engineers. So what percent of Qualcomm employees are engineers?
70.
70.
70.
And 30% are non-engineers. And IoT stands for what?
Internet of Things.
Internet of Things.
Internet of Things.
Does. Yes, it does. Good job. Okay, so now what we're going to do in the next week is, if you look at page 11, we're actually going to be using the engineering design process. You are going to identify a need, and need may be that you simply have to make a hat that does certain things. So we will identify the need and the constraints. You're going to brainstorm how you can come up with a design to suit those purposes. And what you do in the engineering design process, we're going to talk more about it on Wednesday, but it's really about going through similar to the scientific inquiry process, where you're going to be asking some questions and thinking about solutions. The biggest difference with an engineering design process is you're going to build a prototype. So you're going to build a prototype that you're then going to be able to test. You're going to be able to decide if you need to change it or redesign it, and then you're going to share it. And that's another important aspect of the engineering design process. So what we're not going to be doing today is this week is write that patent, but you're certainly going to have information available that you could write a patent. And then if you were to build something that you wanted to sell to other people, you'd have to go through production and produce a number of those things so that you could benefit from your invention. Next slide.